Hi, everybody. Welcome to SCI-Arc. My name is Elena Manfredini. I'm the graduate program chair here at SCI-Arc. And this is one of our internal lectures for the graduate thesis students that during the summer 2021 are working on their projects. This lecture series is called Format, and this year the theme of the classes that we're going to listen to is expanding the archives. People that are going to lecture in this lecture series have been asked to share with us their ideas about archives and their personal work. And today I'm going to introduce John Carpenter, who is a friend, a colleague, and I've been looking at his work for some time. He was very close to SCI-Arc with his previous office, and I brought many times the students to see what he has been working on. John is an artist, a designer, and also he's an educator. And he works with code and software to create visualization of the world around him. He's based in Los Angeles, and right now he works as at HRL Laboratories, and also he's a visiting lecturer at USC in the School of Cinema and Arts. Prior to joining HRL, John worked at Oblong, which is where I met him. And he has been the lead prototyping person to build a gesture-based interactive real-time interface. So he does something very difficult, which is to manage a lot of data in an intuitive way. He has also worked at Morphosis Architecture, so he understands architects, and also at the Biological Imaging Center at the California Institute of Technology. He earns his MFA from the Design Media Arts at UCLA, so we're all growing here, and also his BS in Molecular and Cellular Biology from University of Arizona. Thank you, John, for being with us, and we're looking forward to see your work.
Well, thank you very much for that introduction, and yeah, I'm really excited to give this talk. Yeah, it's exciting to look back at this. It's been a little while since I've looked at some of the Oblong work, and yeah, yeah, I think it will be perfect for the class and very relevant to archives and data. So the talk is going to be divided into two parts today. One is sort of the trajectory in and out of grad school. And then part two will be some of the work that Elena spoke of and that she saw when she visited Oblong and brought students through. So it should be a lot of fun. I think I wanted to start with the grad school trajectory part, because when I was in grad school, I was really concerned that I didn't have everything figured out. And looking back at my last two jobs didn't even exist when I was in grad school. So it's certainly good to have some of that pressure to figure things out. But I followed the things that I was most interested and passionate about and worked hard and was really fortunate to land in some positions where I got to sort of create new jobs at really cool places. So as Elena mentioned, I got my degree in molecular biology, and most of my friends and colleagues went off to med school or grad school, and I went to work at Caltech for David Kramers, who's the Caltech conceptual artist. And he was doing research looking at Van Gogh's brushstroke techniques and the type of information that Van Gogh was able to capture in those paintings, and was applying it to diffusion tensor imaging of mouse spinal cords. And so this here, I mean, we're starting with kind of an interesting, we're starting with, oh, can I get rid of my little continue? There we go, cool. We were starting with like an archive of data, right? This is a 9-dimensional data set that has been turned into a painting. And you can see a healthy organism over on the left and a diseased organism over on the right. And then this painting, this data visualization, was able to turn that data into something that could sort of see into the future. It could predict which organisms would get encephalitis. And it also created real clear qualitative and quantitative pictures of what was going on. So the color of the brushstroke and the angle of the brushstroke and the density of the brushstrokes all gave the researchers different levels of information or different dimensions of information about the data that they were looking at. My work at Caltech was, or amongst a lot of projects, was this Mouse Atlas project. And that's where I got into code, and that's where I got into sort of interaction design and UX design. And this was built in Flash because that was cool back in 2003. It's what everybody used. And the point of this Atlas database was to share anatomical data with other researchers. So people could come to this site and say, hey, I'm interested in what typical mouse anatomy looks like at a certain point, and they could download that data and also kind of search through it and look at it on these pages. Yeah, so I'd been at Caltech for 4 or 5 years, and then Tom and Morphosis got the astrophysics building at Caltech. And I'd been in academia, I graduated, and then I worked in another, Caltech is an academic institution. And I kind of was interested in trying something else. And David, who I worked for, was on the architecture committee at Caltech and introduced me to Tom and Anne-Marie Burke. Here's Annie. So she helps run the School of Architecture at UCLA now, but they introduced me to them. I said, hey, some of these ideas that we've been working on with systems and interaction design and nonlinear ways to progress through data would be applicable to your research. And Tom was like, yeah, that sounds cool. Let's we'll give you a shot and let's do it. And I worked in the business development group because they kind of didn't know where to put me. And one of my primary functions was to help Tom put his presentations together and help sort of get all of the company's visuals into a place where he could use them, and he was happy with them. One of my first jobs was to go through the print and model archives with Tom over a summer in the Santa Monica office. And that was like 2006 or so, 2007 maybe. And it's funny, at the time it was like, oh man, this worked. But in retrospect, it was this incredible opportunity to get to talk with Tom and find out, learn more about how he thought and how he approached systems and architecture, and seeing these works that are largely collected in his Tangents and Outtakes book from '93 was really inspirational to me, and it shaped the way I approach visualization and looking at spaces. So in particular, some of these like 2D sectional drawings where he's pulling 3D elements out and adding all sorts of interesting layers and shadows of other systems in the work. This has been really inspirational to me. So that was an amazing opportunity. So so here's a nice little case study of the type of work we're doing. So typically the architects would do these case studies with axonometrics or exploded axos of different programmatic elements in the building. And I said, okay, well, let's use some of this interactive media to do this in nonlinear ways, and let you sort of build those components up and break them down in any way you want. And Tom really liked that, because Tom likes to present and kind of make things up on the fly. Well, not make things up on the fly, but he likes to be able to respond to his clients or to the audience and be able to reshape things on the fly so that he can communicate kind of whatever idea that they're interested in. So we'll go through kind of a quick history of interactive media types. Like this is director, which is another thing that probably I would guess 98% of people on this talk have never heard of. But it was sort of an in-between point between Flash and Unity. And so eventually we ended up, these are director still, but eventually we ended up in Unity building applications for him to be able to present to clients or at lectures and things. And we were able to capture kind of all these pieces of the system. You could turn on circulation and you could turn on structural, and it would allow him to sort of go through and talk about the work however he liked and however related to sort of the slides before and after. And we still had some of the classic things that everybody always loved, like these exploded axos, and you could do nice transitions between them. And then as time went on, we used Unity in more interesting ways, where we created these walkthroughs where clients could go explore the building ahead of time and get a sense. Basically video games for people to go explore their buildings and see where they might be lecturing or where their office would be. Okay, so last part of this sort of introduction is grad school at UCLA, and I was fortunate enough to be able to work with Casey Reese and Jennifer Steinkamp, among other professors. And I went to grad school because I'd been working with interactive media and software and code but I didn't really have official training in it, and I kind of realized that I needed to have a higher degree, like an MFA or PhD, to do some of the work that I wanted to do, like teach or work at some of the institutions that I wanted to be at. So I went to grad school and I studied natural systems and ways to represent them with code and ways to interact them with with gesture or different new devices. And so a lot of that work was simulating natural systems with code. So this is kind of a fun little study based on a flower in Oregon. And figuring out fun ways to use things like the Kinect sensor to an optical flow to drive motion and interaction. And again, like I mentioned earlier, I didn't have this super clear path on exactly where I wanted to be, but I knew that I liked immersion, and I knew that I liked gesture, and I knew that I liked code and interaction design. These are a couple other pieces that sort of combine those two things. They're sort of simulating natural systems and creating interactivity as a way to more intimately experience sort of some of these observations that I had of nature. This wasn't my thesis work. My actual thesis work was shoreline equivalent, and I unfortunately don't have any great videos of it. But the piece was a series of drawings of waves that would move up the floor and up the wall and back, and as people sort of walked around in them, they could interact with them and cause new patterns and systems, and the system would sort of constantly evolve and change. This was all back before Kinect, actually. So I was doing like IR blob detection and tracking in the space. It was kind of fun. I'm still doing installations from time to time. It's been a little while. This was a piece in Germany a while back. Oh, Justin Schrake. Well, I'm going to talk about him in a little bit because he and I worked on some projects like this together, and then we did a lot of work at Oblong together. So we'll see his name again. But yeah, a lot of recent works kind of involved Kinect and just these fun explorations of form and shape and time. Most recently, a lot of the work's just been on Instagram, and if you're interested in sort of random studies, that's where I post a lot of this kind of stuff, and that Elena and I talk on there from time to time and keep in touch. And there has been some interesting artifacts that have grown out of some of that work and collaboration. Okay, so here's sort of the real part of the presentation. It's looking at some of the gestural interface and immersive design work that I was doing at Oblong. So I worked at Oblong from 2012 to 2020, and I was part of the advanced technology group. So we did a lot of the prototyping and explorative design that made its way into some of the other products in the company. And we also did a lot of custom client work with people like IBM. Star navigation that looked at Hipparcos and Kepler data of nearby star systems and exoplanets.
Right, when you use a mouse, your hand is down here on the mouse pad.
Yeah,
it's not even the same.
Skipped a slide. Okay, so Oblong. People always kind of think they've heard Oblong before, and they're trying to place it. And so basically, to give you that background, John Underkoffler founded Oblong in 2006. After working on the movie Minority Report with some of a team from MIT, and he went on to work on a number of sort of iconic gesture and visualization scenes like Iron Man and some other movies. And he founded the company to make this technology reality, and a lot lot of it was based on
right, when you use a mouse, your hand is down here on the mouse pad. It's not even the same
MIT.
plane as what you're talking about. The pixels are up on the display. So here was a room in which all the walls, floors, ceilings, pets, potted plants, whatever was in there, was capable not only of display, but of sensing as well. And that means input and output are in the same space, enabling stuff like this. That's digital storage in a physical container. The contract is the same as with real-world objects in real-world containers. Has to come back out, whatever you put in.
So
this little design experiment.
A lot of his thesis is really incredible and worth going back and looking at if you're interested in immersive design and like room-based pixel spaces. But a lot of the work that we were doing was based on that research. So I got there, and I found this sort of technology playground where you could kind of do anything and have pixels everywhere and have sensors everywhere, and you could have multiple machines interacting with each other. and multiple sensors interacting with each other. In this case, there's this sort of generative tree L system that's grown on one system and then moved over using the Connect to another system, and then interacted with Elite Motion. And there's just a bunch of this kind of neat stuff here. So here's a mobile device controlling an image across 4 different operating systems, and sort of temporally and spatially synced across all those different systems. This is Alex Valley. He trained, he's a great guy. He taught me a lot of, he made all my introductions to GSpeak and C++ and the frameworks that we were using there. This is one of your professors at SCI-Arc. So we even have done some experiments where we tie physical hardware into the spatial operating environment that we work with. This is a robot arm responding to one of our wands that's being moved around a space, and it's changing your view into a virtual system based on the screen on the robot arm. Pete Hawks worked on that as well from Oblong. So a lot of my work was gesture-based stuff. So I was hired as a designer and a creative technologist, software engineer, to sort of figure out how to use some of Oblong's tools and figure out how to make them more accessible to people other than the 20 people at Oblong on this advanced technology group that always worked with this C++ framework. And there were a lot of hurdles to sort of get over. So they started developing for designers like me who are less familiar with some of the core programming environment to be able to do stuff like these gesture-based interactions with a brain visualization. And it was a lot of fun too, because I mean, this is really similar to the Minority Report work, right? So, and that kind of was a lot of my early inspiration, was like, hey, okay, I'm working at the company that pioneered a lot of these visuals. Let's try to make things kind of like it that we can demo and show off. So this is a pipeline called Antenna that was a custom Oblong pipeline that did a bunch of gesture recognition. Fun stuff. Here's another early piece. It's an earthquake visualization, and this one's run across, I think this is one machine, but 3 different screens and resolutions. And just the point of it was to explore gesture as a way to interact with data. So I think this is like 5 years of earthquake data across the globe. Yeah, so in addition to doing prototyping, I was also, or IBM hired Oblong in, it was like 2010-ish? No, I started in 2012. It was 2 years after that. So it was like 2014. IBM came to Oblong and said, hey, we want to build some real-time software-based environments to explore Watson API services. And this is sort of the space that we want to create at Astor Place in New York. And we want a big immersive room, and we want a big media wall to do these real-time applications on. So we prototyped that space at Oblong. This looks very familiar to Elena. I'm sure anyone who's visited Oblong up until recently, this was over by the gun club and LAB climbing gym, kind of right catty corner to it. Unfortunately, it's not there anymore. I think a lot of the equipment's at USC now. But we built this kind of really cool prototyping space, and this is where I spent, I don't know, 6 years of my life prototyping cool interactive projects. So a lot of the rest of this talk are some of those cool interactive prototypes for these sort of architectural pixel spaces. So I just wrote a paper that got accepted to Leonardo, and I'll show you that in a little bit. But one of the things I got dinged on in my paper was that I didn't give any precedence for some of the research we're doing. So to do that now, and because this is sort of an educational talk, the Electronic Visualization Laboratory at the University of Illinois at Chicago has pioneered a lot of these cave technologies and research, and they have a really nice product-based system that works with Unity and a couple different things for doing these type of installations. So they're definitely worth looking at if you're into this kind of stuff. And they've been kind of pioneers in this field since '92. They presented at SIGGRAPH on a cave with these super groovy glasses. They were doing some 3D stuff with the screens, but there's a bunch of really interesting work coming out of there. So if you're interested in this space, they're definitely ones to look at. There are also a lot of artists right now that are working in a similar space. So Rafik, which I'm sure a lot of you know, based in LA, did this archive dreaming project with Google. and created this almost cave-like space, but used mirrors across the top and the bottom and got these really beautiful results. It's a stunning project. It's really, really nice. So he's definitely worth looking at as well. And then there's some other designers like Design.io or TeamLab that do a lot of big, immersive, really beautiful presentations. So what's different about our work? What's different about our work? So we're using GSpeak, and it's a spatial operating environment that allows real-time operation and programs to be run in these sort of architectural spaces. It allows you to link multiple computing systems and screens and perspectives. And in this case, like that hexagonal room that we started with for IBM was 5 computers running 45 screens and 93 million pixels. And how we do that is there's an origin in the spatial operating environment. So there's a physical origin in the physical space that all of the screens are calibrated to. So every pixel in space has an X, Y, and Z position and an orientation. And that allows the system to determine how to correctly render visuals. And so that allows us to do things like gesture to fly around and move through systems. It very much becomes like the ship of the imagination. I approached my design here like I was creating large virtual environments and then flying and moving through them in the system using the gesture interactions. So to flip over, like a lot of what we're doing for IBM was, hey, okay, we have this huge data set and we have our services. How do we navigate these huge data sets? So a lot of my work was to prototype using our software and using our technology to explore how I might look at large data sets. This is Iliad or something. I'm kind of, I think it might be the Iliad, broken up into, I think we just did a test on word length and put it into separate layers and exploded them out as a way to sort of interact with it. And it's fun. It's kind of a way to follow intuition in my design work. This piece didn't turn into anything. It was kind of a fun demo, but it did lead to some of this work where we were looking at large image sets and trying to find interesting ways to interact with them. So what IBM would come in and say is, okay, so we're going to use some of our machine learning and our image classification as a way to analyze the image sets, and then we're going to combine that with interesting UX and UI design as a way to sort of explore this data in a new way and see new things. So the bottom right is sort of the closest to what was actually installed eventually. And okay, so back to the hexagonal room. So a lot of my favorite work was actually creating interfaces based around these like the screen architecture. So this is kind of a little series of some prototypes that I did for one of the early works installed at Astor Place. And this piece was an installation that looked at a bunch of different companies and gave viewers and clients sort of augmented views of the company based on sort of data that was publicly available and associated with them. So this is the actual installation. This is one of those like 3 a.m. videos where you finally got the thing to work and it's the night before the install. It was a fun way to interact with the data and see a bunch of different perspectives on it. Here's another fun series of prototypes. This one never turned into something. That led to another piece, but this was looking at like 12 or 13 dimensions of sales data for an organization. And the point of it was to be able to sort of really quickly look at it all and find points of interest like this big blue spike. And the idea was like, okay, what's that big blue spike? Why is it only in that time? So 360 degrees was 1 year, and then there was a bunch of data normalized and extended up based on whatever factors we were interested in looking at. So this piece went through a lot of iterations. It became this like big cylinder that went out into space. My favorite iteration of it though was this sort of spherical version of it that we called the Death Star. And again, each band, each loop around the sphere was that 360 degrees was 1 year, so January to December. And all the data was normalized and exploded off the sphere. There's also some kind of other neat little interface elements that I guess are outside of the view of this video, but I applied a lot of what I knew from architecture to this too. So there's sectional planes that show over on the left, and there's like floor plans of each level over on the left as well. So that work in combination with this little prototype led to News Discovery, which was a project we did with IBM Watson and Jenny Wu, who is the IBM design lead that I worked with. And what this application did, okay, so if you've been like watching the soccer game or something like that, this is the one project Elena asked me to sort of make sure I talked about and that we tended to demo. So this one looks at 40 to 60,000 English news language articles every day and does analysis on them to look for sentiment and concept extraction and location extraction, and creates this huge news aggregator and explorer that allows you to sort of look at the news in a new way and explore connections in the news. We did a bunch of interesting UI work. We had these neat expandable and collapsible interfaces where every element that came up would sort of take center stage and offset some of the other elements that you're working with. So here's so you can see a bit of that. So how it would work is you would select a concept from any of the thousands of concepts that were floating around you, and you could dive deeper into it and eventually sort of narrow these 50,000 news articles down to 400 or 20 or whatever kind of refinement you were interested in, whatever filtering you were interested in. And this very much was in lines with, again, the story that IBM liked to tell. Hey, there's a ton of data out there. We can help you make sense of it through good design and through Watson services and APIs. Okay, so here's a little demo. We already, we were down to 263 articles at this point because I've selected 2 different concepts. I have sentiment analysis on around those concepts. I have the concept extractions on and a few concepts selected. And now I'm sort of circling the globe. You can kind of get an idea of the global reach of an idea or a concept here. And then at that point, you can say, okay, well, let's see the headlines of some of these articles of these 263 articles. So that's what I'm doing there. I'm panning through these articles, and then I'll select one, and it'll offset the globe over or all the way around to the other side of the system and bring up, go back, and bring up the actual article over on the right and bring up Watson's analysis of it and sort of tells you the factors it's seeing and what it thinks of everything. So that was a fun project, and I think very relevant to the class topics and ideas that you're covering. I went through my archives and kind of found a couple other fun little data-focused and gesture-based studies. These are all photogrammetry studies of forget where, but these were done with local projects. I have their name later on. So a lot of the asset production and design was done with local projects in New York and of course for IBM. But yeah, so here's some LiDAR data prototype. This turned into a pretty fun project. Originally, we started with these like blocks of LiDAR scans of New York, and eventually we moved towards this modeled version of New York as a way to interact with the data. So this was a disaster response module talking about how Watson could sort of enhance first responders' abilities to respond to some emergency. And the idea of the work was that it created this sort of augmented city view that gave you all sorts of additional layers of information that were related to the decisions that these first responders needed to make. Yeah, and so as you can see here, you could sort of dive into the city, and basically these modules were created for like an experienced leader to talk to potential clients when they came into the IBM spaces. We also did some supply chain work, looking and building these immersive systems for volume should be down on this one. Looking at how certain events could affect supply chains. of fun, interactive real-time systems. And again, there's a lot of this, like, right, you can do it it can be non-linear. You can choose a bunch of different ways to organize stuff and go through it based on, you know, what the audience was interested in or what they kind of wanted to talk about. These are a couple other sort of just prototypes that never really turned into anything. This is kind of stuff that ends up on Instagram a lot of the time as a way to just sort of track some of the stuff I'm thinking about and ideas that I'm talking about. This is another sort of node-based system. We were looking at complex networks, and this is just a simple L system branching out, but we're just sort of distorting it in some different ways and letting it grow out in different ways. And then this and how information progresses through them and is edited. We also did, you know, sometimes these prototypes did turn into interesting projects. This is an application that was designed to talk about machine learning and image classification. So, you know, a lot of these things, like machine learning or image classification, you know, there are some visuals associated with them, but they might not be entirely informative to someone who doesn't understand the research. So we created these sort of visual metaphors for what was going on. This was just kind of a fun test, but it looks cool, so I left it in there. But so I called Justin out here. So he's J2RGB on Instagram, and a pretty cool designer. He's at Magnopus now, which is also in the neighborhood down there by SCI-Arc. And you know, we did a lot of this prototyping and design, and would go back and forth, and he would come up with a system, type something with 4 million, and he'd have to redesign it. And yeah, a lot of really fun things grew out of this, that collaboration. Like the Sprite Swarm application that allowed us to do these big, you know, million particle system simulations in the space. And here's another one. Okay, yeah, and here's, I'm not sure how this looks on your guys' end, but it's kind of a mess on this end too. This was a test to see how many particles we could get flying around and still sort of do some neat things. Anyway, so to end, and I apologize, I went through stuff a little bit faster than I want. There's still a couple minutes of things, but this is the research that just recently got accepted to Leonardo. It's some heart visualization work that I did with Dr. Rusty Lansford from Children's Hospital and USC in LA. And here's Rusty talking for a second.
First trimester of development. We try and study how organs form normally, and then when things go a little bit wrong.
And so Rusty and I were friends from Caltech. He was there when I was there in Scott Fraser's lab, but he'd come by the office to visit, and I showed him some of this research. This is a brain visualization that we did as a prototype back actually when I started the company. And, you know, he saw this work and said, hey, you know, I've got this research, that looks like this, you know, that actually kind of reminds me that some of the brain structures, like, do you think we could figure out some interesting way to visualize it? I'm having a lot of trouble seeing the things that I want to see. I'm having trouble seeing the relationships that I want to see, and I'm having trouble isolating some of the cell movements that I'm interested in. So I wrote some custom software for him that allowed us to do things like retrospective analysis, where you can select a region and see where the cells started before they migrated there. It allowed you to sort of parse through time. It allowed you to immerse the user in the data. And here was sort of one of the first installation tests, which was really fun because it immersed you in a really neat way. And you know, I realize there's other immersive technologies out there that definitely have advantages. AR, MR, VR. I'm sure you'll talk to some people that work in those spaces. And one of the key advantages of like AR or MR is that you can get a HoloLens and you don't have to do you know, couple, I'm not sure how much these systems were, but a big system with 45 screens and 5 computers is pretty pricey pretty quickly. And so like I said, there are some advantages to something like AR and VR, but I really enjoyed working with these pixel spaces because they were very architectural in scale. They defined space in an interesting way, which I found encouraged collaboration and interaction, and those sort of the physical presence of these screens a lot of times help ground people and orient them in the spaces. So, you know, and we had access to them. So, but you know, as we were working with them, Rusty sort of really found that, you know, he could sort of access the information he wanted to, and he was seeing new things, and he was able to experience the data in new ways and talk to other people about it and present it in new ways. So, yeah, we wrote up this paper on 40 image sets for Leonardo development, and that'll be in Leonardo sometime in the next year. I'm not sure exactly when it comes out, but the paper is already out there if you go search for it. Yeah, so like I said, I went through it really quickly. We could have conversation. I have some fun stuff at the end too that are just like random studies that I did that we can look at as well. But you know, what would be most valuable? Do you think it would be fun to have, you know, questions or conversation, or talk more about any of the pieces in the presentation, or to just show some?
You can tell us what is next. I think it would be great to see the rest of the work, and maybe you can just tell us what is next. Because I think some of the work you do is really speculative work. You have an intuition about something that will then you build the technology towards it. And I'm wondering, you already told us a bit about what is the difference between the Oblong and 24 screens or AR and VR. And I think you gave us somehow a trajectory there. But what do you think is next in terms of data visualization? It's maybe one of the most interesting questions.
Yeah, well, you know, I think it, in the near future, it's probably going to be iterations of some of the technology we have. So I think AR, like the HoloLens, keeps getting better. And I think there's a huge amount of potential with the HoloLens and mixed reality. That's sort of one of the spaces that's most exciting to me. We are going to continue to get some of these like physical spaces. I think there's an incredible amount of opportunity for integrating pixel-based technology into architectural spaces. And there are some companies at, you know, I was looking for something new before I ended up at HRL, and I talked to Gensler and some different companies that are doing some really interesting pixel-based integration over the last year or two. A lot of that sort of public space-based digital installation stuff has kind of gone away because of COVID, but I think that'll come back, and I think there's really interesting potential iterations of this kind of stuff all over. Like the stuff John was talking about, you know, like this idea that every surface in a room could be an input and an output device, could show you something. You know, you could see that, you see it in the movies now. I could imagine that being some interesting architectural projects where you look at how embedded pixels or embedded technology in architectural spaces could be used for all sorts of interesting things. And I know people are doing that. And then, you know, there's really, the HoloLens guys did a collaboration with JPL looking at Mars data. That was a really fantastic project. And I think that's an indication of where some of the technology could go. So they had groups of people interacting with, they all had the HoloLens on, and they had a shared, some similarities to this. They had a shared physical space that the virtual space was overlapped with, and they were able to look at rovers, and they were able to look at data from the surface of Mars. And yeah, so I'm not sure. That's probably not the most exciting answer in the world, but I do think there's going to be some really interesting iterations of this kind of technology. So higher resolution AR glasses and more integrated pixel surfaces where you don't even see the screens because either they're behind some veneer or they're, you know, directly integrated into some material. That I think, you know, maybe the super near future. And then I think kind of our experience with that and how people figure out to do interesting things with it will sort of help define what the next technology is or what the next evolutions of it are. Does that sort of answer the question, or did I?
No, it's great to hear from you. Yes.
And I'd love, if there's questions or anything, I'd love to hear, yeah, love to have a conversation about it, about stuff. I can show some, yeah, like, oh yeah, did somebody have a question?
I think there is one question from a student. I then had one as well, but I can read the question from this student first. It's from Barack. It says, thank you for the great presentation. When you showed the morphosis example, I realized that interactive presentation could also work as an instant feedback-based meeting with clients. Where do you think it's going to be in the next years?
So kind of, oh, are we talking virtually or are we talking physically, or how? So client interactions, yeah, I totally agree, and they're definitely on an area that a lot of people are doing a lot of research in and spending a lot of money on right now, like Zoom or Oblong or some of these different companies. But
yeah, well, I don't want to speak for Brock. Brock, I don't know if you just want to ask the question. You could just.
I think when you said the HoloLens and the Unity example, it was super related to the client meetings, and I believe the interaction between them, both sides, like the architect and the client, would meet the topic. I guess it doesn't have to be AR or VR or mixed reality with HoloLens, but I believe when you showed the example of morphosis, I thought it could be anything interactive and work as a two-sided like dialogue between architect and the client, I guess.
Yeah, so that's a great, okay, yeah, you're fantastic question. You're talking about a lot of the things that are sort of being talked about right now in the circles that I'm in, and those are all great problems to be thinking about. I mean, so one, I can give you a little bit of, okay, so some of these examples where Rusty and I are talking. So this was a really interesting experience, and or even, okay, let's come back to this one. Let's go a little bit further back. So this system back here, oh, even the globe one, that's a good one. Okay, so this news discovery. So I created a version of this initially that you could rotate the globe in any direction you wanted. And the whole idea of this was to give this to an experienced leader to be able to drive this system. And when you could rotate this thing in any way that you want, really quickly people would get lost and disoriented, and the data wouldn't be aligned correctly. And there's some things you need to think about. So there's a balance between the amount of freedom that I think you give your audience or give your user, and that you create. I'm all for giving all the power to the user and the person driving the system, but I very quickly discovered that someone like me who had worked with this system a bunch and developed it over 6 months could do anything I wanted and not get lost, not misorient the system. But they, within 30 seconds, had things upside down, or like off the screens. Like there's no bumpers on a lot of this system. So if you wanted to, you could grab the Earth and put it off the screen and then just lose it. And then like, and that happened. And there were bugs where, you would grab the system and the gesture detection would detect that, and you would move it, and it would lose the release of the gesture and just send this thing off into space. And then, so I had to respond to that. I had to create like a reset gesture. So you could point down and click at any point in the thing and create a way to like recenter the data, reset the entire system, take off all the filters. And it's, it's a very, there needs to be a bunch of conversation in this type of stuff, because these systems, yeah, I found that sometimes it's good to place some bumpers and limitations on sort of what people can do. But I bring that up because I think in, when you are creating these immersive, interactive, augmented experiences for a client and a user or collaborators to be talking about, or to sort of share ideas or information or conversation or insight, you will run into some of those complicated, tricky issues. And I started there because that was a good one, because we had globes flying all over the place, and it was kind of funny. But back to this research with Rusty, like even at this point, even when he'd been in the system for a while, like there were the gestures were fairly straightforward. Actually, they were more complicated, and then we simplified them in order and limited them in order to create sort of an experience that he could drive as well. But if you look here, like I think I'm driving most of the system. There's two wands in the one above, which is kind of fun. Actually, that's an interesting point for you too. So like Rusty and I are both, you can see there's two little pink boxes floating around, and that's because we can both drive this system simultaneously. But even that introduces complexities, because like well, it could be neat. It could be like I could grab the system and he could rotate it, and that's kind of fun. That would be neat. And we did that, and it was cool. But then we could both try to grab the system and rotate it, and then how do you decide who has priority there? And typically we assigned like the first user, the first person to engage in an activity got ownership. But it could also make things complicated, because if two people wanted to do something different, you could get conflicting actions. And that's one of the other reasons I actually really like these sort of architectural spaces as a way to explore the data. Is you had more sort of one-on-one interaction with the other person. I could look at him in the eye and sort of see what he was thinking about or communicating about, and there wasn't, like I said, I love MR, I love VR, AR. Like I think there's a ton of potential there, but there are some advantages to all the different technologies. I think, to get back to Elena's question, I think, where's the future? Like where beyond just those iterations? I think the really cool thing that I want to see, that I started to work on and then just didn't happen, was tying like these spatial operating environments, these architectural systems, to AR and VR, so that you could have a big architectural space with pixels everywhere, and wear your HoloLens or whatever and go over and grab something out of that virtual screen space and pull it into the physical virtual space. And I think that's an interesting next step. The spatial operating environment that Oblong uses allows you to do that kind of thing. I just never got far enough along to actually prototype it. But I think that could be a really cool space to work in, is how do you tie and connect all these different immersive augmented technologies to each other? That should have been the first answer I started with. Anyway, did I answer any of your question?
Yes, you did. Thanks so much.
Okay, cool.
So inspirational. Nice.
Thanks.
Thank you.
Yeah, great question. You're thinking about all the right stuff. So,
John, I'll ask a question. Maybe the students will have another one in the meantime. Thank you for your presentation.
Yeah.
And I definitely, Barak is one of my students, but I have a couple of students who are really thinking of, you talk here like we were both in the system together in a way. You talk, right? And a lot of our students are working in like downtown Los Angeles as their architectural site, and thinking of ways to augment the environment in different ways. And I just wonder, after you've spent so much time in this kind of immersive system, I wonder what happens after a day, a week, or even years now, when you leave this environment, you go back into the city. What do you see the city differently, or do you expect different things, or does the city seem so slow to you now, or like as if it's hiding so much information? And I just get curious how you see the city maybe differently after seeing all of these layers in the interior world that you've created.
Yeah, that's a great question. This is really cool. And I don't think I've been asked this before, so I'm trying to think on the fly about it. I mean, so I think there's a couple different parts to this answer. Like one, I think I've always, I think, seen things a little differently. Like I'm always looking at relationships between objects in space, like that dandelion piece that we looked at. How did we go through 80 slides in 40 minutes? I have no idea, but we managed to do it. And I kind of figured I would. I practiced earlier and it was like 45 and I'm like, okay, that's fine, we'll talk. But all this stuff is, the sort of spatial relationships in these systems is what's so fascinating to me. So this flower that has, it's a relatively simple structure, right? It's got these sort of links going out of it, and it's got sort of this fluff associated with it. But the relationship, I've always been fascinated by this kind of thing. And I'll sit there and look at, apparently even when I was younger, I did that dandelion. I still love dandelions. And I'm like, oh, okay, that makes sense. But I'd love to just sit and look at something and watch it rotate and watch it move through space and think about how it changes through time. I mean, this goes back to the biology stuff, right? Like the developing organisms or embryogenesis. And I, you know, looking at things in relation to each other, how they move through time, how trees blow in the wind, how, you know, all those things. So I'm always looking at that kind of stuff. And I think that informs my work, especially with natural systems a lot. But then, you know, from the technology aspect, yeah, like I think John's talk is probably the most interesting reference there. But just this idea that, I don't know, or even Team Labs, some of their stuff, right? That just have pixels everywhere and have these incredibly immersive experiences that are constantly churning around you. You know, I think I do look around and see opportunities for that. And oh, I skipped over John's stuff. I did, yeah. I mean, I think there are some really. All right, so there's two more parts to that answer. So one, yeah, I look around, I see opportunities all the time. Like I think there's some really neat places where, I mean, signage is a really obvious one, right? Like immersive signage that could respond or move with people. Or there's that scene in Minority Report where it's terrible. Like it's not the future I want, but Tom Cruise is walking through and there's ads all in his face all over the place, right? Like that's not, that one's not that appealing to me. And there's been other pieces that are done sort of like that. But there are a bunch of interesting opportunities for sort of helpful augmentation like that. And then I think maybe the third part of the answer is like, are there image artifacts, or like, you know, if you're sitting inside of, you know, how if you're out surfing or in a boat or something like that, and you get off the water and you're moving still a bit and that over thing. And I think there's a bit of that as well. And sometimes, you know, I typically don't have much in the way of motion sickness or, you know, I've never really had trouble with stuff, but we did get to, like some points, like this system could make people pretty sick pretty quickly. And I did discover, you know, I do have some limitations on the amount of information that I can have going around me. And for exactly that reason. So you'd sit in here and it would become disorienting quickly because you'd sort of get this real sense of vertigo or movement as you know, you could see where Justin was sitting. So we would sit kind of like right in the center of the system. You stop paying attention to it and stuff's going by on the sides and background, you start to get kind of a bit of vertigo. And so when we were working with some of these more intense systems and coming out of it, yeah, that kind of stuff did happen as well. But I actually think that's one of the reasons I kind of like the architectural installations as a method for immersion, because yeah, if you're not trying to test the limits of your system and yourself by creating some crazy installation, you know, I tended to have a pretty easy time with, you know, motion in these systems, even if it was something like food or something.
Great.
That's very indicative of the way I think as well. It goes all over the place and explores like 3 or 4 different possibilities of things. And did we hit any? Or yeah.
Yeah, no, for sure. I just always find it fascinating, people that put themselves in extreme situations in their research, especially spatially. Then I feel like you're the type of person that then comes back and has a lot more expectations of what architecture can do and what the city can do. Yeah.
Well, I mean, I think even these, okay, so we figured out a way to talk about some of these. So like, this is just the kind of stuff that, you know, I'll see a flocking algorithm and be like, hey, can I wrap that around a sphere so that everything lines up? And then maybe let's assign color to them based on their direction or orientation. And a lot of this stuff are just these kind of experiments where, you know, hey, can I apply different forces interacting with each other, or different, yeah, like you said, this is very intuitive. I'm like, I want a sphere and I want little spikes coming off of it. And I want little balls at the end. And then I want trails at the end because I can, and this is what happens. and then let's apply a noise force to it and see what kind of shapes it makes. And does it make kind of like a sea dragon, or what are those little guys called? Anyway, does it make some undersea organism that is evocative of that, or is it evocative of an embryo or something like that? And I mean, a lot of my sort of personal studies and work are these little explorations where you're trying to see, like, hey, can I take data? So this is from like an iPhone 12, right? I just use the face scanner in it and start distorting it with noise and putting and running shaders over it, and it's fun. I've kind of always worked this way, very intuitively. It's interesting being at HRL because it's a very sort of research focused scientific institution, but I'm incredibly lucky because the researchers have given me quite a bit of leeway to be intuitive, and often I'll be working on something like this and then come back and say, oh, that's actually an interesting way to deal with a scientific problem or this visualization problem that we have, and figure out some interesting way to sort of think about, how does something move through time, or how do you look at potential of something? And yeah, so I don't know. I found Instagram's been a nice way to sort of, as an interesting public place to put some of those things and to be able to have conversations with other artists and designers about them. I don't know. All this stuff is spatial too, right? They're all 3D scans that I'm messing around with.
I think you do a fantastic job at visualizing things that are very ephemeral and difficult to understand. And I think nowadays data has been, we need to look at data. I think we cannot even be an architect or designers without looking at data. It's not that we design with this anthropocentric view, but we need to look at a lot of numbers and things that might not have an easy visualization. I think your work, it's very important for architects because it allows us to see things that organize patterns or visualizations that are not that easy to find. And I think making something comprehensible of something that usually is not that comprehensible, it's a very important design task for anybody today that needs to deal with systems that are this complex. So thank you for being here, and thank you the students for participating in this lecture. Next week we'll have a new guest. John, thank you for your fantastic contribution to our formal lecture series.
And thank you so much for bringing that point up at the end, because that's actually one of the points that I meant to make. What are those filters that, and what are those methods that allow you to sort of see those patterns? And that, again, that's another one of my focuses. So I meant to say that, but thank you. This is why our conversations are always great, is you always figure out kind of what I'm trying to say with the 80 stuff, and then sit down into a couple.
Fantastic. Thank you so much.
Yeah, thank you very much.
Thank you. Thank you, John.
If we're doing research or anything like that that's related to any of this, I'm happy to talk to people over email or anything.
Fantastic. They might.